Hello everyone. We're just going to do about 4 extra proofs with the triangles today. So if you would like to take these down in your own notes or just kind of watch and pause as you need to, you are more than welcome to do that with this video today. So with that, we're going to get started with the first one. So for the first one, we know that ADB and CDB are right angles, and we know that A to B is congruent with B to C. So we're going to start with that. That's going to be our given. That's going to be our first statement. And I am just going to put both of those together. So ADB and angle CDB are right angles. And we know that A to B is congruent to C to B. And our reason for that is given. Now, moving on, since it has a right angle, we know that we can use hypotenuse leg for this one. We know that A to B and C to B are the hypotenuses of both their triangles. So we just really need to find one of the two legs. And looking there in the center, we can see that BD is shared between those two triangles. Let me try to redo that so it looks a little bit nicer. So that we can say for our second statement that BD is congruent to itself because of the reflexive property. Now, since we have that right angle and we have those two sides, we can say that the two triangles are congruent. So we know that triangle ABD is congruent to triangle CBD. And our reason for that is hypotenuse leg for this one. All right, so there's the first one. We're going to move on to the second one. If you need to pause it to give yourself a little bit more time, please pause it and give yourself a little bit more time there. So for the second one, a little bit of a different given here. We know that A is the midpoint of that segment from E to B, and we know that angle E is congruent to angle B. So it only tells us one congruent statement, but we're going to be able to get that other one from midpoint. So like the last time, we're going to start with our given. A is the midpoint of E to B, and angle E is congruent. That congruent sign was really bad too, I'm sorry. It's hard to write on my Chromebook here. Is congruent to angle B, and that's our given. So very similar to how we did it in Unit 1, is we're going to use that definition of midpoint, or that word midpoint, to say that E to A, that was ugly again, I'm sorry, but E to A is congruent to B to A. And we know that up in our picture because A is that halfway point between E and B, or A is that midpoint. So our reason for that is then going to be definition of midpoint. And I can't spell. Now, looking at the picture, we have two things that are congruent, so we need a third one. And if you look here at A, we have the triangles going opposite directions, so we have those two vertical angles. So we're going to list that down here next. That angle EAD, that's our top vertical angle there, has to be the same as the bottom vertical angle, which is BAC. Okay, as we talked about already, that's our definition of vertical angles. Now from there, we have our three pieces of information. So now we can do our triangles are congruent. So we can do that triangle EAD is congruent to triangle BAC. And this one, if we look up there for our pattern, we have the angle at B and E, we have the side there, and we have the vertical angles at A. So our pattern for this one is angle, side, angle. So very similar to the ones that we've already done, just throwing that other vocab word of midpoint in there back from Unit 1. All right, so once again, if you need to pause there to kind of get caught up, feel free to pause there and get caught up. I am going to move on to 3 and 4. Okay, so moving on to number 3. For this one, it tells us in our given that we have two sets of congruent sides. So we know that A to B is the same as C to B. And we also know that A to D is the same as C to D. So we have two sides there for our given. So we're going to start with that. Oops. So A to B is congruent to C to B, and A to D is congruent to C to D. Now, one other thing to notice on this one is that our prove is that two angles are congruent. So we're not only just trying to prove that the triangles are congruent here, we're actually trying to prove that a specific part of those two triangles are congruent. So it's going to look a little bit different there when we get to the end, but we'll talk about that then. Now, looking at my picture, the other piece of information I can get is that those two triangles share a side, that BD that goes down the middle, so I can mark that it's congruent to itself. And then as we kind of talked about in the first one, what allows me to do that is that is the reflexive property. So B to D is congruent to B to D. And as we said for that first one and just now, that's the reflexive property that allows us to say that. Now, if we look at our picture, we have those three pairs of sides. So we can now go and say that those two triangles on either side are congruent. So ABD is congruent to triangle CBD. And it was three pairs of sides, so that's going to be because of side, side, side. And this is where most of our proofs will end. But as I said earlier, if we notice up here, our proof is angle A is congruent to angle C. So, since we know the two triangles are congruent, we know all their parts are congruent. So we're going to be able to say that angle A is congruent to angle C, here for part 4. And that's because of that theorem or statement or definition we had back in 5.2, that the corresponding parts of congruent angles are congruent. Now, I'm not going to take the time to write that out, and I don't expect you all to either. We're going to abbreviate that CPCTC. But once again, that stands for corresponding parts of congruent triangles are congruent, is where we get that for. So anytime that we have a proof where it's two angles are congruent, or two sides of a triangle are congruent, we're going to show that the two triangles themselves are congruent, and then we'll use CPCTC right after our shortcut or our congruence postulate to say, hey, since these two triangles are congruent, each of their parts are congruent, even though we weren't given anything specific about those parts. So that's how number 3 would look. Once again, if you need to pause here to kind of get caught up or kind of digest what it was there, feel free to pause the video here. And then we are going to go on to the last one, which is number 4. All right, so number 4 throws in another vocab word in there. That's from Unit 1 and Unit 2, that word bisect. So as we've kind of talked about, bisect means that we're going to cut an angle in half, so we're going to have to digest that, kind of like we digested midpoint in the second one. So if we go to our picture, it told us that A was congruent to C, and it tells us that BD down the center there bisects That should be ABC, not ABD. So I'm going to correct that here real quick. I'm sorry that that is incorrect in there. I missed that earlier. So instead of ABD, we're going to change this to be angle ABC. My apologies for that mistake right there. That will make this a little bit easier to do when we go look at that bisect. So when I come over here, ABC is this big angle right here. BD cuts that in half. So I know this left side is congruent to this right side. And that's from that word bisect. So now we just need to go to our proof and start writing that part down. So we have angle A is congruent to angle C. And we have that BD bisects angle ABC. These are our two parts. That's going to be given. Now, we've kind of already wrote that on our picture, but since we have that word bisect, we're going to use that definition next. So we're going to use that definition of bisect. And we've already marked this in our picture, but we need to then write down that those two angles up at B, ABD, and CBD are congruent to each other. So our second statement here is going to be that A to B to D, that angle, is congruent to the angle from C to B to D. And that's our definition of bisect there. Now, just like the last one, since it's that same picture, we can go mark that B to D down the center, since they share that side is the same. So you're seeing another reflexive property there. BD is congruent to itself. And as I just said, that's because of the reflexive property. Those two triangles share that side BD down the center. And now, if we go back and look at our triangle, we're looking for which of our congruence postulates or which of our congruent shortcuts, which pattern do these two triangles follow. So I can say that ABD is congruent to CBD. And this time, unlike having side, 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 like we just had for 3, this one, the angles that it gives us 2 angles. And then that side B to D is not between the 2 angles that we know. So it's going to be angle, angle, side. Or if you're someone who uses side, angle, angle, SAA, that would be fine as well. Now, real quick before we decide that we're done, once again, we didn't want to show that 2 triangles were the same. This time we wanted to show that AB is congruent to BC or CB. So since we know the 2 triangles are the same, we can use that CPCTC, or that corresponding parts of congruent triangles are congruent, to then come down here and say that, hey, these are corresponding sides in those 2 triangles, so we know that A to B has to be the same or congruent to C to B. So that's how that last one looks. If you need to pause that there to kind of look at that, digest it, and pause it more, feel free to pause it here before the video ends. But that's how those proofs will kind of look. So your assignment today, that's Justin McGraw-Hill. We'll have just a whole lot of matching with those. You will see CPCTC once or twice, but for the most part, it's just working at, hey, how do we use definition of bisect? How do we use definition of midpoint? How do we use reflexive property, vertical angles, and then those 5 shortcuts that we've talked about. So side, 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 SSS, side, angle, side, SAS, angle, angle, side, AAS, angle, side, angle, ASA, and hypotenuse leg, which is HL. So you can go work on that one. There's also an extra credit paper that I gave you yesterday that you can feel free to work on that has these same proofs. You're just filling in both sides like we did here for your notes as opposed to just filling in the blanks. So I hope you all have a good day. If you have any questions, please let me know.